Checking your answers on number 5, you should have gotten 0.707. On number 6, 0.667. On 7, 0.785. And on number 8, 0.785. Now, if you take a moment, you'll notice that these two numbers are the same. And actually, if you were to type in pi divided by 4 in your calculator, you'll see that that is 0.785. So these two answers are actually the same thing as pi over 4. On number 9, you should get 0.268. On number 10, 86.19. And on 11 and 12, you should get 15. Again, same answer. On 13, you should get 0.866. On 14, 2.12. On 15, negative 0.524. And on 16, positive 0.524. And again, if you were to type in pi divided by 6, that is this decimal that you're getting here. Okay, so the sign's the opposite, but it actually is the same thing as pi over 6. Now the idea here is that if you're dealing with a trig function and its inverse trig function, they cancel each other out. Just like in chapter 4 when we talked about if you have an x squared, then its inverse function is the square root of x, because to undo a squared you use a square root. It's the same idea here, where if you start off with sine of x, if you want to undo sine, well, then you use sine inverse to get rid of sine. So on this side, underneath the big box that says rule, sine inverse of sine of x equals x. Now, this is not always going to be the case, because we found up here where we had some does not exist. Okay, so we're kind of generalizing right now, but that's okay. We'll get into more detail later. Same thing here. If you have sine of sine inverse of x, the signs cancel each other out, leaving you with just x. Same idea for cosine and cosine inverse and cosine, tan inverse tan, and tan inverse. Okay, so the big idea here is that an inverse trig function undoes a normal trig function. And this is really useful for when you want to solve equations. So go to your notes for a moment. And let's take a look at solving a trig equation. So if you had tangent squared x equals 4, and you were asked to solve for x, the first thing that you need to remember is that anytime you're dealing with tangent squared of x, that's the same thing as writing tangent of x squared equals 4. So if we want to get x by itself, first thing we need to do is get rid of the squared. So we'll square root both sides. So this becomes tangent of x equals plus or minus 2. To get rid of the tangent, we use our inverse function. So we'll just slap a tan inverse on both sides of the equation. So on this side, cancel out, leaving us x equals tan inverse of positive 2 and tan inverse of negative 2. And at this point, you use your graphing calculator. Now, since there is no label on the 4, like there's not a degree symbol, go ahead and assume that it's in radians. So on your graphing calculator, make sure that you are in radians. And then we need tan inverse of 2 and tan inverse of negative 2. So our two answers are going to be that x equals 1.107 and x equals negative 1.107. And that's it. We solved our equation. Let's look at another one. So let's say I asked you to solve cosine of x equals 1/2. All right, so we need to get x by itself. That means we need to get rid of the cosine. So to do that, we'll do cosine inverse on both sides of the equation. On the left-hand side, those cancel out, and we're left with x equals cosine inverse of 1/2. Again, there's not a degree symbol, so we'll just assume that it's radians. And we get 1.05. And that's your answer. Now let's say we started off with an inverse trig function to begin with. So if we had something like 3 tan inverse of theta equals pi. And in this case, we're trying to get theta by itself. So we need to move the 3 first. So we'll divide both sides by 3. So this becomes tan inverse of theta equals pi over 3. Now, to get rid of tan inverse, we're going to use tangent. So we'll apply tangent